Hello dear students, this is Mr.Muhammed Azeez. Welcome back to another lesson. In this lesson we're going to explain 4.3, which is about limits at infinity. Firstly, limit at infinity means horizontal asymptote. So whenever you see any limit that x tends to positive infinity or negative infinity, that means we're going to find horizontal asymptote. This line is horizontal asymptote. As x tends to infinity, it is on 2, or when x tends to negative infinity, it is still at y equal to 2. That means y equal to 2 is horizontal asymptote. Now let's have more examples about horizontal asymptote. So this is a rule. If the result of limit x tends to infinity or negative infinity is a number, then that number is going to be horizontal asymptote. If we rewrite this rule, let's say limit x tends to positive or negative infinity for fx, result is a. That means y equal to a is horizontal asymptote. So HA is the shortcut of writing horizontal asymptote. There are three very common cases about horizontal asymptote, which are extremely common in the book exercises, in Wazari questions. These are three cases of finding horizontal asymptote easily. First of all, if degree of up is greater than degree of down, then there is no horizontal asymptote. If the same question came back as limit, result will be infinity. Second case, if degree of up is less than degree of down, degree of up is less than degree of down, then there is horizontal asymptote, which is y equal to 0. Finally, if degree of up and down are the same, then the coefficients 3 over 4 will be horizontal asymptote. When we say degree of up and down are the same, we are watching the highest power, highest degree. All right? Here we have space to write an example, and usually we call this example eye test because they do test your eyes in the exam. Okay, let's see. The question says evaluate limit x tends to infinity 2x minus 3x squared plus 4 divided by 3x plus x power 2 minus 4. Now, what is the result of this limit? By the way, let's clarify something. Whenever you see limit x tends to infinity, or whenever you see question asking about horizontal asymptote, these are the exact same thing. Let's give it options. A, 2 over 3. Let's make it more precise. A, y equal to 2 over 3. This is the result. Is it? You might say power of up is up and down. The powers are the same, then 2 over 3. That's not. Because the highest power is the leading power. So the leading power for the numerator is 2. The leading power of the denominator is 2 as well. Then the right answer will not be 2 over 3. The right answer is B. The right answer is B because the highest power in the numerator is 2. The highest power in the denominator is 2 as well. Then divide their coefficients. Negative 3 divided by 1 is negative 3. You can write this extra example. Okay. Finding limits. Step 1 for evaluating every limit is to replace. Here, I'm going to replace every x with infinity. I'm going to have 5 minus 2 over infinity. Any number divided by infinity is 0. We have a note here. Number divided infinity is 0. Infinity divide number is just infinity. Infinity divide infinity is undefined. We need to use simplifying. We need to use L'Hopital. We need to use left, right, whatever. Just when you see infinity over infinity, we cannot decide. Just like the case of 0 over 0 in chapter 2. Square root of infinity is infinity. E power infinity. Ln of infinity. These are given. Now, I know 2 divided by infinity is 0. 5 minus 0 is still 5. This question, if it's asking for find horizontal asymptote of this function, we just do limit, and result of limit is 5, so y equal to 5 is horizontal asymptote. This example, let's do it. We put infinity in place of x, we'll get 5 minus 2 over square root infinity. Square root infinity is infinity. 5 minus 2 over infinity. 2 over infinity is 0. Then final answer is 5. So y equal to 5 is horizontal asymptote for this function. This example, degree of up and down are the same. Up, x is power 1, down is also power 1. Then the result of this limit is directly 2 divided by 1, which is 2. Here is the answer. Or, if we replace infinity, we'll get infinity over infinity. Then we're allowed to use L'Hopital. Derivative of up is 2, derivative of down is 1. 2 divided by 1 is just 2. This example, the degree of up is 2, degree of down is 2 as well. Then the result will be 3 over 2. We are also allowed to use L'Hopital because the result will be infinity over infinity. Now we have 3 examples here. All the 3 cases of horizontal asymptote are in one question. Number 1, degree of up is less than degree of down, result is 0, directly. Degree of up and down are equal, then result is 2 over 3. And here degree of up is greater than degree of down, result is infinity. The sign of the infinity depends on the sign of this infinity here, and these are all counted. Same questions, we can solve them using L'Hopital, or there's another way. Whenever you see limit x tends to infinity, we are allowed to divide everything by x. So it's better to divide everything by x with the highest power in denominator. This is a way to solve limit x tends to infinity. L'Hopital, you already know, we studied in chapter 3. And the note, which is the easiest, is also quite efficient. This constant, explain in your own words that what the statement means. Limit x tends to infinity equal to 4. That means 4 is horizontal asymptote. For this one, limit x tends to negative infinity of fx equals 2. That means horizontal asymptote for this function is 2. That's it. Now we have 4 functions to match. Functions 3, 4, 5, 6 to be matched to the graphs of A, B, C, D. Okay, whenever you want to match graphs to functions, just do point plotting. We might use a little bit of horizontal asymptote, but overall, point plotting is the final decision maker. Now, number 3. What is the horizontal asymptote? Since the power of up is less than power of down, y equal to 0 is horizontal asymptote. Y equal to 0 is horizontal asymptote. Which of the four graphs has the horizontal asymptote on 0? D. See, this is horizontal asymptote. This dashed line is horizontal asymptote. How do I know it's horizontal asymptote? As the curve goes farther from 0, it's getting closer to this line. Okay, now I know number 3 belongs to D. D. Now, number 4. Number 4 degree of up and down are the same, then y equal to 3 is horizontal asymptote. Is there any graph that has the horizontal asymptote on 3? Let's check. Yes, B. This is 3, it's between 2 and 4. This horizontal asymptote is 3. That means B belongs to number 4. Now A and C are remaining with two equations of 5 and 6. Number 5, horizontal asymptote is 2. Y equal to 2 is horizontal asymptote. Number 6, y equal to 2, this 2 is horizontal asymptote. And I'm going to explain how for number 6, y equal to 2 is horizontal asymptote. I'm going to explain this later. First part is a fraction. Horizontal asymptote for the fraction is 0, but this constant, 2 plus 0, is 2. That's horizontal asymptote. That means for number 5 and 6, I cannot make the decision based on horizontal asymptote. Then I go back to point plotting. Point plotting is the very efficient way to match function to their graphs. I'm going to calculate f of 0 because 0 is easy to calculate. It's going to be 2 times 0 squared minus 3 times 0 plus 5 divided by 0 squared plus 1. Result is going to be 5 over 1, which is just 5. Make the calculation point. X is 0, y is 5. Now, point 0.05 must be on the graph of equation number 5. 0.05. 0.05 is right here. This is 0.05. If I look at the other graph, this point is no 0.5, it's 0.2. Now, I'm sure graph C belongs to number 5. Which means the last graph, which is graph A, belongs to number 6. Because if I put 0 in place of x, I will get 2. And 0.02 is on the graph of A. So number 6 belongs to A. More exercises. These are extremely easy. The result of this question 8 is 2 over 3. Question 10 is infinity. This question is 3 over 9 simplifies to 1 over 3. This one is going to be like this, number 11. If I put infinity in place of this x power 2, it will look like this 1 over 2 multiplied by negative infinity. As I told you before, the signs really matter. Negative infinity squared. Negative infinity power 2 is just infinity. 4 divided by infinity is 0. 1 over 2 times negative infinity. Result will be negative infinity minus 0, which is just negative infinity. This limit is negative infinity. If the result of limit is negative infinity, that means we don't have horizontal asymptote. This question, in question 12, this is where the result becomes infinity over infinity and L'Hopital fails. Why L'Hopital fails in this question? If you remember in chapter 3, we had a question like this where L'Hopital failed. What makes L'Hopital fail? Two conditions. Condition number 1. Condition number 1. If the limit x tends to positive or negative infinity. That's one condition. Condition number 2, if there is x power 2 under square root. Whenever you see these two conditions together in any limit question, L'Hopital fails. It doesn't mean that the limit does not exist. The limit might exist, depends on the simplification, but we cannot use L'Hopital. If we use L'Hopital, it will be like a loop. It's just repeating the function. It keeps getting infinity over infinity. That is not clear, and we cannot make any decision out of using L'Hopital. Then what we do, we're going to divide everything by x. Every single term of the function will be divided by x, and then simplify, then try to do the limit again. This question, most importantly, the limit x tends to negative infinity. That means these x's are going to be replaced with something negative. This is why I'm going to divide every term of the function by negative x. So x divided by negative x squared divided by negative x squared, minus x divided by negative x squared. Why did we make these squared? Since we sent x and a radical, then the x becomes power 2 to not lose value, okay? Whenever you want to divide everything by x and there is radical, inside the radical we have to divide by x squared to keep the value. Then there is a lot of simplifying. X squared cancels x squared, becomes 1, minus, this is going to be x over x squared. X cancels 1 power of the x, the negative outside stays, and x divided by negative x is negative 1. Now, if I try again doing the limit, I only have this x to replace with negative infinity. When I get this, result will be 1 over infinity, which is 0. 1 plus 0 is still 1. Negative 1 divided 1 is negative 1. There's a fast way. The fast way is also very efficient. It works all the time. How is the fast way? Secretly, we can consider this x power 2 under square root as x. Then if we consider this as x, then up is x as well. This goes back to the case where degree of up and down are equal. The result of this limit is going to be the coefficients. Coefficient of this x is 1. Coefficient of this x power 2 is radical 1. And since the limit x tends to negative infinity, add a negative, result negative 1. The fast way is clearly explained on the next page. Functions with two different horizontal asymptotes. The functions that L'Hopital fail, they have two different horizontal asymptotes. Why? Because when x tends to infinity, we just write the coefficients, and when x tends to negative infinity, we do write the coefficients and we write one extra negative. That makes the result of the first limit and the second limit to be different. And whenever we have two different results for limit x tends to infinity and limit x tends to negative infinity, that means we have two different horizontal asymptotes. Let's do them. Now the coefficient of x here is 3. The coefficient of x squared under radical, which is just like x, is 2. This 2 is not a normal 2. It's under radical. Square root 2. This is the result of the limit. It might be not in the simplest form, so we divide or we multiply up and down by radical 2. So it's going to be 3 radical 2 over radical 2 times radical 2 is just 2. This is the result of the limit when x tends to infinity. And for the same function, if we do limit x tends to negative infinity, we get an extra negative, then write 3 over radical 2. That simplifies just like this one to negative 3 radical 2 over 2. Now I have two different results for limit x tends to infinity and limit x tends to negative infinity. That means I have two different horizontal asymptotes. There might be a auxiliary question asking for which of the following functions has two different horizontal asymptotes, and one of the options is a function in this form where L'Hopital fails. If we look at the graph of this function, it's like an S shape, but the S is not a perfect S, unlike the odd function x power 1 over 3, which is a perfect S. Okay, the right side has this horizontal asymptote. It's getting close to this dashed line. The left side is getting close to this dashed line. That means this function has two different horizontal asymptotes. Another extra example, fast way, is explained here. Very efficient, it works all the time. Some limits won't have result when x tends to infinity. That means the function does not have horizontal asymptote. For example, x power 3, replace infinity with x, we'll get infinity power 3, which is infinity. If the result of limit x tends to infinity is infinity, that means the function does not have horizontal asymptote. Here, x power 3 doesn't have horizontal asymptote. When x tends to negative infinity, result is negative infinity. That means the function does not have horizontal asymptote. X power 2 is the same on both sides. The result is positive infinity. That means the function x squared, fx equal to x squared, does not have horizontal asymptote. Limit. More examples. Degree of up is greater, result will be infinity. Degree of up is greater, result of limit will be infinity. There is another type of asymptote. In the beginning, we studied vertical asymptote in chapter 2, and now we studied horizontal asymptote. It's time to study the third type of asymptote, which is called slant asymptote. Slant asymptote happens if degree of up is 1 more than degree of down. Power of x in the numerator is 2, power of x in the denominator is 1. That means degree of up is 1 more than degree of down. This is the case where slant asymptote happens. So in such cases where degree of up is 1 more than degree of down, start with dividing the numerator by the denominator. Result will be slant asymptote. We're going to use long division. You might say, oh, long division again. Don't worry, this long division is way easier than the long division you studied in grade 5, and until now you didn't understand. This long division is easier. It's always 1 or 2 steps, not more. Nothing mysterious. We have function where degree of up is 1 more than degree of down. We just do long division. Now let's do long division. We do the division sign. This is the divisor, x plus 1. And here 2x squared minus 4x. Listen to this carefully and make it a note. If you feel like you'll forget, write what I say. This is how we start the long division. Starting with this x. X multiplied by what term becomes 2x squared? X multiplied by what term or what value becomes 2x squared? Then obviously 2x. If x is multiplied by 2x, it becomes 2x squared. Okay, multiply 2x by x and 1. 2x times x is 2x squared. We really need to make this term as it is, with the sign and everything. 2x squared, 2x squared, that's correct. Now 2x multiplied by 1 is plus 2x. We say after multiplication, change the signs. What do you mean? I mean, after you did multiply 2x by both terms and we got these two results, change the sign. This 2x squared is positive and I make it negative. This 2x is positive, make it negative. Don't remove the old sign. When you see two signs like this, You know this is the new sign. You already changed the signs. You did not miss any step. The upper sign is the working one. Now 2x squared plus negative 2x squared cancel out, becomes 0. Don't write it. Negative 4x minus 2x is negative 6x. Now again, look at this x. X multiplied by what term becomes negative 6x? That's obviously negative 6. Negative 6 multiplied by x is negative 6x. Negative 6 multiplied by 1 is negative 6. After multiplication, change the sign. That's negative, change it to positive. Negative, change it to positive. Now negative 6x, positive 6x cancel out. Final answer is positive 6 remaining. Now I can write this rational function 2x squared minus 4x divided by x plus 1. I can write this as slant asymptote 2x minus 6 plus. Why plus? Because this 6 at the end is positive, so I write plus. 6 divided by x plus 1. So the remainder is always like this. 6 divided by the divisor x plus 1, or we can say same denominator, 6 is the remainder. What is slant asymptote? We have been talking about slant asymptote for so long. This linear function, this linear part alone, this is slant asymptote. This green highlight is slant asymptote, okay? Now we have a rational function that degree of up is 1 more than degree of down. That means there is slant asymptote. This linear function, which is the result of the division, which is right here, this linear is slant asymptote, and this one is the remainder. The remainder usually is not important, but since it's in the book, we don't skip anything. This is how we do the long division. And if you don't learn the wrong division right, long division will be wrong division if you don't learn it right. And everything is written here clearly. Firstly, we look at x. X times what becomes 2x squared? X times 2x. 2x times x is 2x squared. 2x times 1 is 2x. After multiplication, change the sign. Now add them. These two cancel out. These will be negative 6x. Now again, look at x. X multiplied by what value becomes negative 6x? Obviously negative 6. And then after multiplication, change the sign. Negative 6x cancels positive 6x. What's remaining is only positive 6x at the end. We can write the rational function in this form. And what is slant asymptote is this linear part only. This linear part, 2x minus 6, is slant asymptote. What is slant asymptote? Slant asymptote is this line, this dashed line, because it's tilted, it's not vertical, and it's not horizontal. And it is asymptote because the curve is getting close to it. Then this is slant asymptote. We have two more examples that they have slant asymptote. As degree of up is 1 more than degree of down, you just do long division, you find slant asymptote. Now let's solve this question. This is my own question. There could be a question in Wizari asking for the values of A, B, and C. Let's see. When you look at the question, there is a rational function given. Degree of up is 1 more than degree of down. And there is a linear part here. And then there is a fraction next to it. So I know this thing is about slant asymptote. And I also know slant asymptote is about long division. Let's do the long division. Repeat the process here so you can understand. Firstly, we write the division log, long division sign. Here is x plus 1. And here 2x squared minus 4. X multiplied by what value becomes 2x squared? That's 2x. 2x multiplied by x is 2x squared. 2x multiplied by 1 is plus 2x. After multiplication, don't forget, change the sign. Now 2x squared and negative 2x squared cancel out. What's remaining is negative 2x minus 4. Since this is constant, this is x, they are not the like terms, we don't add them together. We just write them next to each other. Now again, look at x. X multiplied by what value becomes negative 2x is negative 2. Negative 2 multiplied by x is negative 2x. Negative 2 multiplied by 1 is negative 2. After multiplication, change the sign. These two cancel out, and this will be negative 2. Finally, I can write 2x squared over minus 4 over x plus 1, which is the rational function, as 2x minus 2. This is negative minus 2 over x plus 1. Now comparing, 2 is the same. A is negative 2. See, it's plus a, but here it's minus 2. That means the value of a is negative 2. B is here. The minus is matching, so the b alone is 2. And c is right here. C is next to plus. 1 is next to plus. They have the same position. C equal to 1. The question is asking for this calculation. Then a plus b plus 2c is negative 2 plus 2 plus 2 times 1. The result is 2. That makes A the right answer. I hope you find it useful. This is the end of the session. Thank you so much for watching. Inshallah, I will finish the book soon.